We use fire in many different ways to suit our different needs, and we use many different kinds of fuel. Here we use fire to get rid of rubbish. The fuels are waste materials from about the yard. Raking keeps the fire under control. When we use fire to cook our food, gas may be the fuel. The burner knob controls the size of the flame by regulating the flow of fuel that reaches the burner. When we use fire to heat our homes, coal may be the fuel. Furnace fires are controlled mainly by adjusting the draft opening on the ash pit door. When we use fire to produce light, kerosene or gasoline may be the fuel. Turning a knob regulates the flow of fuel and controls the flame. But whatever the purpose of the fire, or the kind of fuel, or the method of control, all fires depend upon the same principles. In order to learn more about fire, let's study the campfire these boys are building. Dry bark and twigs are good to start the fire, and the boys have heaped them at the center of the pile of fuel. They have chosen a site in a clearing so that the campfire can't spread out of control. Larger branches will keep the blaze going after the bark and twigs burn out. Now the pile of wood is ready. Heat from the match flame soon sets fire to the bark and small twigs. In a few seconds, there is enough heat to set fire to the larger twigs. Finally, the branches begin to burn. Because these must be hotter than either bark or twigs before they will take fire, we say that branches have a higher kindling temperature than bark or twigs. The boys want a bigger fire, so they do two things. First, they bring more branches and place them on the burning heap. Also, since they know that the fire will burn faster if the circulation of air increases, one of the boys fans the flames. The branches just added take fire quickly. With the campfire burning well, and with plenty of fuel to keep it going, the boys stretch out to enjoy its cheery warmth. When we watch a fire burning, we must keep in mind that we cannot see all that is actually happening. What are some of these important actions? For one thing, gases are given off from the heated pieces of wood. Here, black dots represent these gases. Oxygen, represented here by white dots, is part of the air surrounding the fire. When oxygen joins with the wood gases heated to their kindling points, burning takes place. As the oxygen and the heated gases burn, another gas, carbon dioxide, forms. The black dots joined with white dots represent carbon dioxide. The large black circles represent unburned soot particles that rise as smoke. All the while, fresh air flowing in at the bottom of the fire supplies needed oxygen. The fire burns as long as there is fuel and oxygen. Now, let's consider some ways of controlling fire. In this cook stove, the amount of fire is regulated by a knob. When it is turned on, the fuel gas flows into the burner. It draws oxygen along with it through the air intakes. Burning starts when this mixture of fuel gas and oxygen is heated to its kindling temperature. When this mixture is turned off, the flame goes out. Now let's see what happens in a coal-burning furnace. The rate at which the coal burns and gives off its heat depends upon the amount of oxygen supplied. The supply of oxygen is regulated mainly by the draft door. Now let's see how this affects the burning process. With the ash pit draft door only partly open, a moderate supply of oxygen flows into the firebox. As the coal burns, carbon dioxide and smoke form as they did in the campfire. The carbon dioxide and smoke escape through the chimney. We open the draft door wider to make the fire burn faster. Now, the largest possible draft of oxygen reaches the fuel and speeds up the burning. Although fire under control may be helpful to us in many ways, fire handled carelessly may cause trouble. This girl should have made sure the match flame was out. Fortunately, she knows what to do. Pouring water on the flame does two things. It cools the fuel below its kindling temperature, and it shuts off the oxygen supply. Many accidental fires begin when small children play with matches. This little boy has seen his parents strike matches, so when he finds them lying around, he wants to try it too. But this new plaything gets too hot to hold. The panda bear takes fire, and the situation is beyond the child's control. It's a good thing that Mother is close by and can come to the rescue. The thick rug shuts off the oxygen supply, and the fire goes out. Some fires start from faulty wiring, such as a frayed lamp cord. The bare wires touch and flames leap up. This home has a fire extinguisher handy, and the boy knows how to use it. How does this liquid put the fire out? Once in the open air, the liquid quickly changes into a gas. This gas will not burn. Instead, the gas builds up in layers around the burning fuel and gradually shuts off the flow of oxygen into the burning zone. Cut off from its oxygen supply, the fire goes out. We have seen that three things are necessary for fire. First, we need fuel. Second, we need enough heat to raise the fuel to its kindling temperature. Third, there must be a supply of oxygen. Without oxygen, there could be no fire, even though we have plenty of fuel and enough heat to raise the fuel to its kindling point. We have seen examples of controlled fire as we use it to burn trash, to cook our food, to heat our homes, and to furnish light. We have seen three ways of putting out accidental fires. First, by cooling the fuel below its kindling temperature. Second, by shutting off its oxygen supply using mechanical means. And third, by the use of a chemical. As long as we keep fire under control, it serves us well.